Robert Solis. Welcome to this video lesson where we're going to be talking about KMaps. Some people just call them KMaps. But Carnot was an individual who came up with this graphical way of reducing circuits, and so I'm going to introduce this to you. So let's say that, for example, I have the following expressions. So I have A, B naught, C naught, that's going to be ORed with A naught, B, C naught, which is going to be ORed with A naught, B, C, and finally that's going to be ORed with A naught, B naught, C naught. And so we want to create a circuit based on this expression, but we have to reduce it first, right? Well, in terms of Boolean reduction, so let's see, I'm going to take this, I'm going to copy and paste it. So here we are over here in terms of the Boolean algebra reduction approach. And so it looks like what we'll do is we'll just simply take the A, B naught, C naught, that's over here. In terms of these two right here, I can factor out the A naught and the B, because that's got an A naught and a B as well. So I factor that out, and that's going to end up with C naught ORed with C. Well, that is just simply going to be 1, because when C is 0, C naught is 1. When C is 1, C naught is 0. So it's always going to be 1. So that ends up being just simply A naught B. All right, and then I just bring this part over here. So now I've got these 3 elements. And what I'll do is, since this has a B naught, C naught, this has a B naught, C naught, I'll factor that out, which means I'm going to get the A, which you see over here. I get the A naught, which you see over here. And so that's going to be 1. And so that ends up being B naught, C naught. I take this part over here, write it over here, and it looks like we end up with B naught, C naught, and that's going to be ORed with A naught, B. No further reduction can be done at this point. I can go ahead and make a circuit. So it looks like B and C are going to be inverted, so that's why you see 2 inverters. They are ANDed together, so you see the AND gate. That is, and then the other component is the A naught is going to be inverted, and that's going to be ANDed with B, so you get that. And then both of those are going to be ORed, and so that's why we have the OR gate here. And that is why we have the output is B naught, C naught, or A naught, B, just like you see over here. Well, that was the Boolean algebra approach. Now let me introduce to you a really interesting way of solving problems like this. That's using what we call Carnot maps. So a Carnot map is done like this. First, you start over here with A, B, and then over here you would have the letter C by itself. So if I had D, then I would say A, B, and then C, D. But we'll say that for another problem. Right now, if you have just 3 elements, this is what it looks like. So I start counting, not in binary. Look at this particular approach. So over here I have 0, 0, 0, 1, then 1, 0 down here, and then 1, 1. So you've got to remember that. Basically what we're looking at is we're looking at kind of like what was referred to as gray code, where we're looking at 1 bit that will be changed from row to row. Okay, so the first bit that will change is this guy, so that goes to a 1. Well, what's the next bit that we can change? Well, we can change this one. So now that changes. Now we have 1, 1. Well, what's the bit that we can change? Well, we can change this one over here, and that goes to a 0. That's one way of thinking about it. The way that I remember it is just simply 0, 1, 2, 3. Okay, so that is how you would arrange these rows. And then since I just have the one variable over here, I just put 0, 1. All right, now what we'll do is we'll take a look at these, and if the letter is not knotted, we'll just simply represent it with a 1. If the letter is knotted, we'll represent it with a 0. So this is really going to be 1, 0, 0, because this is true, false, false, and the knots are what make them false. That's going to be ORed with, okay, looks like it's knotted here, so that's going to be false, true, false. That's going to be ORed with, okay, that's knotted here, so that's going to be false, true, true. And then finally, all of these are knotted, so that's going to be false, false, false. And of course, 0 represents false, 1 represents true. Okay, well, now what I'm going to do is I'm going to take care of each one of these. I'm going to place a 1 when I find this particular situation or condition here. So let me see here, 1, 0, 0. So the 1 is, A is 1, B is 0. So A is 1, B is 0. Ah, right here. A is 1, B is 0. and then C is 0. So C is 0. So it looks like this column and this row, that's one of the items that I'm going to place on number 1 right here. So I put a number 1 right here. Don't worry about these circular curved lines, what have you. Just put the number 1 right here because this is initially blank. I'm going to put a 1 right here. Let's work on this next one here. We need to put a 1 where we have 0, 1, 0. Okay, so 0, 1. And here's a 0 for the letter C, so it's this column and this row intersected. It's this square right here, so we're going to put a 1 right there. All right, next, 0, 1, 1. Okay, so 0, 1, that takes care of this, so that's this row, and then C is 1, so that means that's this column, so that means that with this row and this column intersecting, that's this square right here, so we put a 1 right here. And then for our final term, it looks like I've got 0, 0, 0. Okay, so 0, 0, that's this row right here. Here's the 0 over here, so the intersection of this row and the intersection of this column, I put a 1 right here. All right, so pretend that these lines are not here. You can see here that these 4 terms right here are represented with these 1s right here, because that's how we're able to get the 0, 0, 0, that's this guy over here, 0, 1, 0, that's this one over here, 0, 1, 1, so 0, 1, 1, that's this one over here, and then finally 1, 0, 0, because this guy's got it, 1, 0, 0. Okay. All right, once you've placed the 1s in there, your goal is to either circle 1, 2, 4, 8, 16 1s together. Now, in this case, since we only have 3 variables, you're only going to be able to circle, say, for example, 8 maximum, or 4, or 2, or 1. In other words, something 2 to the n power, right? And we're trying to create the biggest groups that we possibly can. Well, clearly, these 2 can be circled, right? I can combine these 2. That's going to be 2 to the 1, right? So that's 2 together, so I can combine these 2. But what am I going to do with this guy? And what am I going to do with this guy? One of the things you can do in a Carnot map is you can include this one and include this one like here, almost as if this column were like a strip of paper and you connected this end to this bottom end right here. You can think of it like that. That's how you can connect these 2 right here. Now, if this one were over here, then you couldn't do that. You couldn't say this corner and this corner. Nope. It would have to be like a 1 over here and a 1 over here. Then you could connect them. Hey, in fact, watch this. If I had a 1, 1, and then a 1, 1, in fact, I could just group these 2 and then group these 2. But I don't want to jump ahead of myself here. And let me just simply show you how to solve this problem. Then we'll take care of some more difficult KMap problems later on. The goal is you want to circle either the maximum possible. So the minimum would be 1, then 2, 4, 8, 16, 2 to the n power. It looks like I can combine this guy and combine this guy together. It looks like I can combine these 2 right here. Once they're combined, if you wanted to, you could combine additional ones, but why do that? It's already combined, and that's just simply going to add to your terms. We're trying to minimize. So you typically try not to do that. You typically try not to combine them. But I am going to be breaking that rule that I just stated in a future problem. But in this case, that's what you're trying to do, not include them in other groupings. Okay, well, now that you've done that, let's take a look at this. So if I place a 1 right here, then, of course, I'm going to have over here 0, 0, 0. So I put the 0, 0, 0 over here, like you see. And let me see, what else can I also do over here? Over here, for this group, rather, the one that we just worked on, this one is being grouped with this. And so what is that? That's 1, 0, 0. So that's why we have 1, 0, 0. Well, first of all, what you do is anytime that there is a change in a particular column, you don't have to include it. Anytime that there is similarity for a particular column, you include it. Now, in this case, this is column A, this is column B, this is column C. So for column B, all you do is just simply put the word B here. Why? Because they're both the same. See, these are different, so I'm not even going to bother putting a column A here. These are different, so I put a column B. Now, are they 1s or 0s? They're 0, so I put the not of B. Right, so that's why we see the not of B. Now, how about for column C? Looks like they're both the same. Perfect. So I'm going to put the letter C over here. Now, they're both zeros, so we'll put the not of C. Now, if this was 1 and 1, we would just put B. If this is 1 and 1, we would just put C. But since they're both zeros, we put the not of, and over here, the not of. They're different over here, so we don't bother putting A over here. So this is going to be one of our terms right here, B, the not of B and the not of C. All right, let's take care of this grouping right here. So it looks like this guy really is 0, 1, 0. So that's why we have 0, 1, 0. I'll write that down here. And the other grouping member is this guy over here, 0, 1, 1. So 0, 1, 1. So column A, column B, column C. Once again, I'm looking for those columns that are the same. These two columns, or these two rows within this column are the same. So I'm going to underscore that. Now, what column is this? This is column A. Now, there's zeros, so it'll be the not of A. How about column B? I'm going to underline that one because they're both the same. Perfect. Now, 1 and 1, well, that's going to be B. I shouldn't say 1 and 1. That's not what I meant to say. What I meant to say is since column B has both 1s, we can just put B by itself, and I'm not going to put the not of because that's true. Now, these two are different, so I'm not going to underline that one. That's not going to be included in my terms because they're different. Only the ones that are the same will you include. All right, so it looks like I'm able to, using this method, combine this term right over here, which is A naught B, here it is, and this guy, B naught, C naught, and OR them together. So now this expression right here can be reduced to this. Now, was that the same expression as my Boolean minimalization approach? Let me see here. So that's A naught B. There's the A naught B. Or, there's the OR, and then B naught C naught. There it is. There's the B naught C naught. So as you can see here, using the Boolean algebra reduction, I was able to get the answer. Using the Carnot map, I was also able to get that same reduction using this approach. So this is an example using 3 variables. What would you do using 4 variables? Say, for example, so if you had an A, B, C, D, I'm going to show you that next time. Now, the one thing that you want to make sure to remember is that you don't count in binary when you're drawing a Carnot map. You wouldn't put 0, 1, 2. That's not 2, that's 3. Right? So you do it this way. 0, 1, go all the way to the bottom. 2, go up to 3. Right? That's just the way that it's done. And then since there's only one variable over here, this is going to be the 0, this is going to be the 1. The idea is to change these to the 0s and 1s, and so if it doesn't have a not above it, if it's true, you put a 1. If it's the not of, you put a 0. And then once you have all these terms, now by the way, notice that it's this, or this, or this, or this. You have to get it in this expression right here to be able to use the Carnot map, right? So we couldn't do this if it was like, let's say, for example, if it's just this expression. Well, I guess I could do it that way, but what if I had like A, B naught, C naught, exclusive OR A naught, B, C naught? I couldn't do that. I'd have to reduce it so that it's terms, ORed with terms, ORed with terms, ORed with terms, and then once you get it in this standard format, then you could place the values into here that represent each one of these different 4 elements in this case. Circle them into groups of either 1, 2, 4, 8, trying to maximize them as much as possible. So for example, I wouldn't do this. I wouldn't circle this one by itself. I wouldn't circle this one by itself. It's better to circle these two. Now, maybe someone says, well, hey, Professor Solis, how come you didn't circle these two? Well, the reason why I didn't circle these two is because I noticed that this guy can be matched with this one, using that trick of where I circle this one, and I also include this one over here. Now that these two are included in a group, I can include these two in a group. That's what you're trying to do. You're trying to minimize the number of groups using experience, tips, and tricks like this. All right, and so that is a very gentle introduction into Carnot maps. So this is Professor Robert Solis. I hope this lesson was helpful. Have a good day. See you next time.